Hello friends, dear learners and my dear student. First of all, I take an opportunity to welcome you at my M.Sc for Practical Table class. Student, I am Dr. S.R. Labhade, working as Associate Professor in Chemistry at Quantitative College, Nashik. Student, Chemistry for Practical Table. Under this class, we will discuss some theoretical concepts which are essentially required for performing the practical in the chemistry laboratory. Under this study, we discuss the different concepts of chemical analysis, preparation of standard solution, different analytical evaluation methods, as well as how to calculate the concentration of the analyte by using experimental data. Student, in previous lecture we discussed the chemical analysis and different areas of chemical analysis. We know that chemical analysis is the resolution of sample into its proximate or ultimate parts and identification as well as determination of each proximate part for determination of composition of the material. Student, we know that analytical chemistry is a science of determination of composition of material through chemical analysis. And analytical chemistry is a science of determination of composition of material through chemical analysis. The approach of chemical analysis consisting of a series of steps involved in qualitative and quantitative analysis through specific analytical technique and analytical method. Analytical technique is the fundamental scientific phenomenon that has been proved for determination of obtaining information on the composition of material or substance. For example, UV visible, ultraviolet visible spectroscopy is an analytical technique. An analytical method is the specific application of analytical technique in analytical chemistry for analysis of a sample or a substance. Analytical method is an application of analytical technique for analysis of a substance or a sample. For example, identification and estimation of aspirin by UV visible spectrophotometry is the analytical method. An analytical technique is unique, but the analytical method may be different. We know that invisible spectrophotometry is the analytical technique that is unique, but here identification of aspirin by recording its UV visible absorption spectrum is the analytical method. And if we measure the absorption spectrum in aqueous solution, then this will be the one method. If we use a non-aqueous solution or a ethanol solution, then it is a second method. Or if we use its another product, that is its dissociation with sodium hydroxide, then by using NaOH or by using base, then it is another technique of identification. Therefore, here analytical technique is unique, means we can use ultraviolet visible spectroscopy. But if we record the absorption spectrum of aspirin in aqueous medium, then it is one method. When we use ethanol as a solvent, that is second method. If we use a sodium hydroxide solution as a solvent, then it is a third method. That means here analytical methods are different, but analytical techniques are unique. Along with the analytical technique and analytical method, there are two important terminology used in analytical chemistry, that is called as analytical procedure and analytical protocol. An analytical procedure is the written instructions given to analyst to carry out the analytical analytical method. Therefore, here procedure is, that is a written instructions given to the chemist or analyst to carry out that method. That is an analytical method. And here, when more specific, when the more specific description of the analytical procedure is given to the analyst to carry out the analytical method, then it is called as, that written instructions are called as analytical protocol. That means here analytical procedure, that is the written instructions given to the chemist. Heat the sample, then dissolve it into suitable solvent and titrate it with the high acid solution. Such a type of instructions means this is a analytical procedure. But when the description is like this: heat the sample at 90 degree, dissolve the sample in distilled water, then titrate it with 0.1 normal solution. These are the specific instructions. Then it is an analytical protocol. The analytical protocol is worldwide approved. Student, we know that analytical chemistry is a science of determination of composition of material through chemical analysis. And chemical analysis is performed by using different analytical technique and application of their analytical technique through analytical methods. Traditionally, the chemical analysis is carried out. Chemical analysis is carried out by using a traditional methods of analysis, such as a gravimetric analysis, and second one is titrimetric analysis. While second class of chemical analysis, that is a technique of chemical analysis, are the modern methods or a modern techniques. Traditional techniques are the gravimetric and titrimetric. A modern technique of analysis don't specifically involve the instrumental methods, mainly as a spectroscopic methods, then a electrochemical methods, and a separation methods, such as a chromatographic method. Here, the gravimetric and titrimetric methods are the absolute methods of analysis, and here these are the relative or comparative methods of analysis. In gravimetric analysis, we can analyze the sample by weighing its specific compound. In titrametric analysis, we can react that substance or sample with another reagent, and volume of reagent and its strength we can utilize for determination of composition of material. Therefore, directly we can find out the amount of material in this method by using the weight of sample or by using the burette reading obtained in the titration. Therefore, these are the absolute methods of analysis and we can directly determine their concentration. Here there is no requirement of standard solution for determination of concentration of that reagent. Determination of concentration of sample. While in modern technique or instrumental technique of analysis, particularly spectroscopic method, electrochemical method or a chromatographic separation method, these are the comparative method. Means here we can determine the concentration of sample by comparing its results with the standard. Therefore, in this technique, we always require a standard solution for obtaining the concentration of sample. Therefore, these methods are called as relative methods of analysis or comparative methods of analysis. Without standard, we does not determine the concentration of a sample. And concentration of sample in instrumental methods are measured by using a quantitative evaluation method, and this quantitative evaluation method may be a calibration curve method, second one is standard addition method, and third one is internal standard method. Student, in today's lecture we discuss the different quantitative evaluation method required in instrumental analysis, that is particularly for obtaining a result by comparing the standard solution and the sample solution. The quantitative evaluation method can be selected on the basis of following parameters. Number one, nature of sample, that means physical state of sample. Nature means physical state of sample, means whether it is solid, liquid or gas. Second, amount of sample, that is weight or a material available, weight or its availability. Third one is nature of different types of interference present in the sample. Nature of different types of interference in the sample means what are the sample matrix and how that sample matrix interfere in the determination, which can affect the result of the analysis. And most important factor, the sensitivity of measurement. Sensitivity of measurement is related with the level of concentration. If amount we have to determine in decinormal or decimolar solution, then we can use titrametric or gravimetric method of analysis. If concentration is in the order of 10 raised to minus 3 to 10 raised to minus 4 moles, then we can use a spectroscopic method. If less concentration, we can rely on the separation methods or the electrochemical methods. Therefore, here sensitivity of measurement, that again depends upon the quantitative evaluation method as well as selection of analytical technique. Therefore, all these four important factors also determine the nature evaluation methods broadly classified into calibration curve method, standard addition method, and internal standard method. Student, now we discuss what is the calibration curve method. Curve method. It is also called as working curve method. Working curve method, or it is also called as multiple standard method. Multiple standard method. Here calibration, that is a term related with to establish the relationship between the instrumental response and the concentration of analyte. The term calibration means to establish the relationship between the content of sample and response of the instrument. Here the term calibration means to establish a relationship between the concentration of analyte, that is the content of sample, and response of the instrument or instrumental reading. In a ultraviolet visible spectrophotometry, we are measuring the absorbance of solution for determination of concentration of solution. For example, in spectrophotometry analysis, the blank solution means that is a solution containing all components of the sample except analyte. Blank solution must show zero absorbance at the lambda max, that is a wavelength of analysis, lambda max. But when concentration of analyte in the solution increases, then linearly, then absorbance should be increased linearly. When any instrument shows such a behavior, then with the blank and the standard solution of different concentration, then the instrument is said to be calibrated for a particular analysis. That means for blank solution instrumental response is 0. It will be increases linearly when concentration of analyte in the solution increases linearly. When such a behavior or such a condition is satisfied by the instrument, then we can say that that instrument is said to be calibrated. Different instruments are calibrated by using its own method of calibration and the specific standard solutions for calibration. For example, pH meter can be standardized by using a standard buffer solutions. Similarly, potentiometer is standardized by using a standard cell or a cell having known potential, that is a standard electrochemical cell. And here specifically the Western standard cell is used. For calibration of potentiometer. Similarly, a polarimeter, that instrument measures the optical rotation, that can be calibrated by using a solutions having known optical rotation. In this way, different instruments are calibrated by using their own procedure of standardization and different standard solutions which are required. Buffer solutions are not the solution utilized for calibration of polarimeter, because polarimeter measures the optical rotation, and therefore we have to select a standard solution whose optical rotation is known. And now we discuss how to carry out the calibration curve method in the laboratory, how to work out or how to perform the analysis by calibration curve method. Calibration curve method is applicable. Calibration curve method is applicable only when, number one, the nature is composition of standard solution and sample solution is identical. Calibration curve method is applicable when nature or composition of standard solution and composition of sample solution are exactly same. Second thing is that the interference if present in sample does not produce the instrumental response. If sample and standard have a different composition, but if the interference, if it is present in the sample, that does not react at the instrumental analysis, or if interference is present in the sample, that should not produce a instrumental reading, or that should not produce a instrumental response. Then and then only the calibration curve method is applicable. Now we discuss how to carry out this calibration curve method in the laboratory. In order to carry out the calibration curve method, a series of standard solutions of analyte having known concentration are prepared. That means series of standard solution whose concentration is known, that is prepared. That means standard solution and sample solution should have identical analyte. Therefore, a series of standard solution of the analyte are prepared whose concentration is accurately known. Second thing is that during the calibration, then instrumental instrument is calibrated by using these standard solutions. During calibration of instrument, if instrumental response is a linear function of concentration of analyte, then instrumental response is a linear function of concentration of analyte. That means if we plot a graph of instrumental reading as a function of concentration, then we have a straight line passing through the origin. That indicates instrumental response is a linear function of concentration of analyte. And if we observe this during the calibration, then the instrumental reading for sample is recorded. Then instrumental response or reading are plotted on the ordinate axis, that is y-axis, versus their concentration on abscissas, that is x-axis, and a graph called as calibration curve is obtained. Therefore, here instrumental reading versus concentration. If we have a straight line passing through the origin, then we can say that instrumental response is linear. Instrumental response is a linear function of concentration of analyte. here instrument is properly calibrated and it shows its response with linear function of concentration of analyte if we have a straight line passing through the origin. This straight line means y is equal to mx. That is an equation of straight line passing through the origin. This equation indicates that y is directly proportional to x. That means instrumental reading is directly proportional to concentration of analyte. And therefore we have a straight line passing through the origin. From this calibration curve, whatever instrumental reading we have to obtain, that we have to search on this ordinate axis. That is on y-axis. Suppose this is a instrumental reading for the sample. Reading for sample. Then from this instrumental reading, a straight line parallel to concentration axis is drawn up to the calibration curve. Again, this line is drawn towards the concentration axis for obtaining the concentration of the analyte, concentration of sample. In this case, the instrumental reading for sample is searched on this y-axis, and from that a parallel line is drawn from this instrumental reading towards the calibration curve, and from that line is diverted towards the concentration axis, and where it is cut to the concentration axis, that is the concentration of sample. The concentration of sample in this case is totally depends upon the value of m. That is a slope of line determines the concentration of the sample. That means here, if we draw the line in this fashion, then concentration of sample is this much, and if we draw the line in this fashion, then concentration of sample is this much. That means slope of the line directly determines the concentration of sample. Student, this is a calibration curve method. In forthcoming lecture, we discuss the application of calibration curve method in analysis of different types of sample, as well as we discuss how to find out the concentration of a sample by using the calibration curve method. With this, we stop here. Thanks for joining me. Keep learning. Happy learning.